Chris Martinez felt the stares as he walked into the lecture hall at the Galactic Academy of Xenobiology. He was used to it by now, the only human in the advanced evolutionary biology course, surrounded by beings from across the universe who viewed his species as soft and weak. The classroom was filled with creatures of all shapes and sizes. Some floated in gravity bubbles, others perched on specially designed seats to accommodate multiple limbs or unusual body structures. Chris took his usual spot near the back, where he could stretch his legs without bothering anyone. "Attention, students," Professor Zilthrak announced, his insectoid mandibles clicking as he spoke. The tall, thin professor was from a low-gravity world, and his 6 limbs moved with delicate precision as he activated the holographic display at the front of the room. "Today, we begin our comparative presentations on apex predators from your respective homeworlds." Chris sighed. This assignment had been worrying him for weeks. In a class full of beings from worlds with creatures that could swallow mountains or survive in lava, what could Earth offer that would impress anyone? First, presentation, Galnar from Zorbia Prime, Professor Zilthrak called. A large blue-skinned student with 4 eyes rose from his seat. Galnar activated his datapad, and a hologram appeared showing a massive tentacled creature that seemed to stretch for miles. "The void kraken of my homeworld can consume entire ocean ecosystems in one feeding cycle," Galnar explained proudly. "Their neural network can process information faster than our most advanced computers, and their skin can withstand the pressure at ocean depths that would crush most starships." The class chittered and buzzed with appreciation. Chris took notes, increasingly concerned about his own presentation. Next came Lyrith, a crystalline being who shimmered with inner light. "The stone devourers of my world can eat through solid rock like it's nothing," she said, showing footage of enormous worm-like creatures tunneling through mountains. "They have existed for over 2 billion years, and their digestive acids can dissolve any known material in the galaxy." One by one, the alien students displayed their world's most impressive predators. Each seemed more terrifying than the last. Creatures that could fly between storm clouds and feed on lightning. Beings that hunted by stopping time in small pockets of reality. Predators that could mimic their prey perfectly before striking. As the presentations continued, Chris noticed a pattern. Many of these impressive predators had evolved on worlds much less dangerous than Earth. While these creatures might be specialized or unusual, they hadn't faced the constant evolutionary pressure that Earth's predators had endured through multiple extinction events. "Martinez, you're next," Professor Zilthrak announced after the Florvarian student finished showing their crystalline mountain eaters. Chris stood up, feeling his heart race. He had spent days deciding which Earth predator to feature. Lions? 2, similar to other mammalian hunters from different worlds. Eagles. Impressive, but many worlds had aerial predators with similar hunting strategies. Then he remembered his childhood fascination with the one creature that had terrified and fascinated humans for millennia. "Thank you, Professor," Chris said, connecting his datapad to the classroom's holographic system. "Today I'll be presenting information on an apex predator from Earth's oceans that has remained virtually unchanged for over 400 million years. A creature so perfectly evolved for killing that it predates most species in this room by hundreds of millions of years." He paused, noticing a few students exchanging skeptical glances. Near the front, a group of Tridaxian students whispered something that sounded like, "Soft planet, soft predators." Chris had heard it all before. Earth was only classified as a Class 3 death world, nowhere near as dangerous as some other homeworlds represented in the class. "I'm going to tell you about sharks," Chris said, activating his first hologram. The image showed a great white shark, mouth open mid-breach, rows of triangular teeth visible as it launched itself out of the water to catch a seal. The class fell, silent. "Sharks have survived 5 mass extinction events on Earth," Chris continued, growing more confident. "When the asteroid that wiped out the dinosaurs hit our planet, sharks endured. They were there before trees existed on our world, and they're still there now." He cycled through images of different shark species. The hammerhead with its bizarre head shape, the massive whale shark, the lightning-fast mako. What makes sharks remarkable isn't just their longevity as a species, but their design. They are swimming hunting machines. Their entire skeleton is made of cartilage, not bone, making them incredibly flexible and light. Their skin is covered in tiny tooth-like scales called dermal denticles, which reduce drag in the water and allow them to swim silently. Chris pulled up a detailed anatomical diagram. A shark's sense of smell can detect a single drop of blood in an Olympic-sized swimming pool. That's 1 part blood in 1,000,000 parts water. Some species can sense the electromagnetic fields generated by the heartbeats of other creatures, making it impossible to hide from them. He noticed that several students were leaning forward now, their initial dismissal turning to interest. Their teeth are perhaps their most famous feature, Chris explained, showing a close-up of a shark's jaw. Arranged in multiple rows, they are constantly replaced throughout the shark's lifetime. Some sharks can lose and regrow thousands of teeth in their life. Lisa Chen, a cephalian student with 6 eyes and bluish tentacles, raised one appendage. But surely these creatures aren't that dangerous to an advanced species like humans, right? Chris shook his head. Despite all our technology, humans still die from shark attacks every year. We've landed on other planets, split the atom, and created artificial intelligence, but we still fear entering their domain. He played footage of a shark attacking a seal, the speed and violence of the strike causing several students to flinch. A great white shark can accelerate to over 35 miles per hour in a short burst. Their bite force can exceed 2 tons of pressure per square inch. The classroom was completely silent now. Chris continued. But perhaps most terrifying is what happens when a group of sharks detects blood in the water. He played his final video, footage of a feeding frenzy. Dozens of sharks in a violent, thrashing mass of teeth and muscle, tearing apart their prey with mechanical efficiency. The water churned red with blood. We call this a feeding frenzy, Chris explained. The sharks become so consumed with the drive to feed that they may even bite each other in their frenzy. The term has entered human psychology. We use feeding frenzy to describe any situation where group aggression suddenly intensifies. As Chris finished his presentation, he noticed something had changed in the way his classmates were looking at him. It wasn't pity or condescension anymore. It was something new, something that looked a lot like respect. "Thank you, Martinez," Professor Zilthrak said, his mandibles clicking thoughtfully. "I believe we all have a new appreciation for your homeworld's predators." As Chris returned to his seat, he heard someone whisper, "Deathworlder." But this time, it sounded like admiration. The next day, Chris arrived at his xenobiology lab to find a small crowd of students gathered around his workstation. This was new. Usually his alien classmates kept their distance, treating him with polite indifference at best. Now they seemed eager to talk to him. "Is it true that these sharks live in water that humans swim in?" asked Zorn, a green-skinned Verulian whose species evolved on a world with no large bodies of water. Chris nodded as he set down his bag. "Yes. Earth is mostly ocean. About 70% of our surface is covered in water, and sharks live in almost all of those waters. But why would your species ever enter the water knowing such predators exist there?" asked Lisa Chen, the 6-eyed cephalian who had questioned him during yesterday's presentation. "Humans have always had a complicated relationship with the ocean," Chris explained, pulling up images on his datapad. "We need it for food, transportation, and resources. Plus, many humans simply enjoy swimming or diving. We've learned to coexist with sharks, though we still respect their power." The alien students exchanged glances of disbelief. Professor Zilthrak entered the lab, mandibles clicking as he observed the crowd around Chris. "I see Martinez's presentation has sparked some interest," the professor said. "Today we'll be conducting a comparative analysis of predator adaptations across different planetary ecosystems. Please form your assigned groups." Chris found himself joined by Lisa, Zorn, and Gary Peters, a Vespian student whose translucent skin revealed the pulsing of multiple hearts beneath. These were all students who had previously avoided working with the fragile human. "I have updated our assignment parameters," Professor Zilthrak announced. "Each group will create a simulation showing how their selected predators would interact in a neutral environment. Your analysis should focus on competitive advantages and survival strategies." As the group settled around their workstation, Gary spoke first. I suggest we use my homeworld's Void Whisper as our primary subject. They can paralyze prey from a distance using sonic waves. The crystal stalker from my world can camouflage itself perfectly against any background, Lisa added. They all turned to Chris expectantly. He pulled up the shark hologram again, this time choosing a bull shark, one of the most aggressive species. Bull sharks have some unique adaptations, Chris said. They can live in both salt and fresh water, which is rare. They're also known for their aggression and tendency to attack without provocation. Zorn's compound eyes blinked rapidly. Without provocation? You mean they kill when they're not hungry? Sometimes, Chris replied. They're territorial and can be triggered by movement, splashing, or even electric signals that resemble distress. Evolution shaped them to attack first and ask questions later. The group worked together to create a simulation environment, a neutral space where each of their chosen predators could interact. As their program ran calculations based on speed, hunting strategy, sensory capabilities, and attack power, Chris noticed something interesting. Look at this, he said, pointing to the data stream. In direct confrontation, the Void Whisper's sonic attack doesn't affect the shark. Sharks don't have the same auditory systems as other creatures. And the crystal stalker's camouflage is useless, Lisa noted with surprise. The shark isn't hunting by sight. It's detecting electromagnetic fields and chemical traces in the water. The simulation ran through thousands of potential encounters. In most scenarios, the shark didn't emerge as the definitive winner, but it was never eliminated either. It simply kept coming, adapting its strategy, tireless and persistent. What? Is this behavior pattern? Gary asked, pointing to a recurring sequence in the shark's movements. That's what makes sharks so effective, Chris explained. They don't get discouraged. They don't feel fear the way other predators might. If something doesn't work, they simply try a different approach. And they can keep doing this for days without rest. Professor Zilthrak moved to their station observing their work. Interesting findings. Martinez, did your species evolve alongside these creatures? Chris nodded. Humans evolved primarily on land, but we've always relied on oceans for resources. Our earliest ancestors would have encountered sharks whenever they ventured into the water. Some anthropologists believe that our instinctive fear of sharks helped keep early humans alive. So your species was shaped by the presence of these predators, the professor mused. That explains certain human traits. What traits? Chris asked, curious. Persistence, adaptability, the capacity to respect danger without being paralyzed by fear, Professor Zilthrak replied. These are uncommon traits among species from safer worlds. After the professor moved on, the group continued their analysis. They discovered that in prolonged encounters, the shark's endurance gave it a growing advantage. Most predators tired or lost interest. The shark never did. Is it true that these creatures have remained unchanged for hundreds of millions of years? Zorn asked, clearly fascinated. Mostly true, Chris said. They've perfected their design so thoroughly that evolution hasn't needed to make many changes. Why fix what isn't broken? As their lab session ended, Lisa suggested they continue their project in the Academy's biodome during free study time. Chris was surprised by the invitation, but happily agreed. The biodome was a massive enclosed ecosystem containing carefully controlled environments from dozens of worlds. The group found a quiet spot near an Earth section featuring a small artificial coral reef. I've been researching Earth predators since your presentation, Lisa admitted as they settled in. Your world has many apex predators that seem quite dangerous. Lions, bears, crocodiles. Why did you choose the shark specifically? Chris thought about it for a moment. I guess because sharks represent something unique about Earth. They've survived virtually unchanged through multiple mass extinctions. They were there when the dinosaurs died out, when mammals rose to dominance, when humans first evolved. They're living fossils, perfect at what they do. Gary's skin pulsed with colors that Chris had learned indicated deep thought. On my world, we have a concept called perfected evolution. When a species reaches its optimal form and stops changing significantly, it's considered extremely rare. That's exactly what sharks represent, Chris said. But there's something else that makes them special. They're not just killers. They're an essential part of ocean ecosystems. Without sharks, many ocean food webs would collapse. So they're both destroyers and preservers, Zorn remarked. Fascinating. As they continued working, Chris noticed other students glancing in their direction. Word had spread about his presentation. Some still looked skeptical, but others seemed curious, perhaps reevaluating their assumptions about humans and their supposedly soft homeworld. Later, as they finalized their simulation, Professor Zilthrak approached again. Your group's work is quite thorough. Martinez, the Academy is considering adding an Earth Marine Biology module to next semester's curriculum. Would you be interested in consulting? Chris felt a surge of pride. I'd be honored, Professor. As they left the biodome, Chris realized something had changed. His classmates were no longer keeping their distance. Instead, they were asking questions about Earth, about humans, about how his species had managed to thrive on a world filled with such efficient predators. For the first time since arriving at the Academy, Chris didn't feel like an outsider. He had finally found a way to make his alien classmates understand something fundamental about humanity. They came from a world where survival had never been guaranteed, and that had made them stronger than anyone realized. Word spread quickly through the Galactic Academy about the human student and his presentation on Earth's ocean predators. Chris found himself becoming something of a minor celebrity. Students from other departments would stop him in hallways to ask questions about sharks and other Earth creatures. One morning, Chris arrived at the main lecture hall to find it unusually crowded. Professor Zilthrak stood at the front with a special guest, Dean Vorex, the Academy's highest administrator, a tall being with silvery skin that rippled like water when he moved. Due to unexpected interest, Professor Zilthrak announced, today's lecture has been expanded. Dean Vorex has approved an extended session on Earth's evolutionary history, with special focus on predator-prey relationships. Chris slid into his own seat, surprised to see many unfamiliar faces in the audience. Students from advanced years and even some faculty members had come to hear the lecture. Martinez, Professor Zilthrak called. Since your presentation sparked this interest, perhaps you could assist with today's demonstration? Chris nodded and made his way to the front of the hall. The professor activated a large holographic display showing Earth's timeline. For context, Professor Zilthrak explained to the audience, human Martinez comes from a Class 3 death world. While this classification is modest compared to Class 5 worlds like Mortis Prime or Dreadfall, it indicates a planet with significant environmental challenges. The timeline expanded, showing Earth's history from the formation of oceans to the present day. Chris felt a strange sense of pride as he watched billions of years of evolution displayed before his classmates. Martinez, please explain the significance of these extinction events, Professor Zilthrak said, highlighting 5 major points on the timeline. Earth has experienced 5 major mass extinction events, Chris explained. The worst was the Permian-Triassic extinction about 252 million years ago. It killed off about 96% of all marine species and 70% of land vertebrates. The audience murmured in shock. Yet through all these catastrophes, Chris continued, sharks survived. They adapted to changing oceans, food sources, and competitors. While other dominant species disappeared, sharks remained. Dean Vorex stepped forward. I find this fascinating. On most worlds, apex predators are specialized and vulnerable to ecosystem changes. How did these sharks manage to survive multiple extinction events? Chris thought about how to explain it simply. Sharks are generalists, not specialists. They can eat almost anything. Some can live in different water temperatures and depths. When conditions change, they adjust. The dean nodded thoughtfully. And humans? How did your species cope with these harsh conditions? We're generalists too, Chris replied. Humans can eat almost anything, live almost anywhere on our planet, and adapt to new threats. We didn't evolve the strongest bodies or the sharpest claws, but we developed problem-solving brains and social cooperation. Professor Zilthrak clicked. His mandibles and what Chris had learned was a sign of approval. This brings us to today's demonstration. With the dean's permission, I've arranged something special. The large doors at the back of the hall opened, and several academy technicians wheeled in a large tank filled with water. Inside, a holographic simulation swam back and forth, a perfect recreation of a medium-sized reef shark. Through our cultural exchange program, we've accessed Earth's biological databases, Professor Zilthrak explained. This simulation is programmed with actual behavioral patterns recorded from real sharks. The students crowded around the tank, fascinated by the realistic movements of the simulated shark. Its sleek body moved with effortless grace through the water, occasionally turning sharply as if tracking prey. The simulation can respond to stimuli just as a real shark would, the professor continued. Would anyone like to volunteer for a demonstration? After a moment of hesitation, Lisa Chen raised one of her tentacles. She approached the tank cautiously. Place your appendage near the surface of the water, Professor Zilthrak instructed. The sensors will detect your presence. Lisa carefully extended a tentacle toward the water's surface. Immediately, the simulated shark changed direction, moving with sudden purpose toward her. Its dorsal fin cut through the water as it accelerated, and then it lunged upward with jaws open, stopping just short of the barrier at the tank's surface. Lisa jumped back, all 6 of her eyes wide with shock. The other students gasped. That was the predatory response, Professor Zilthrak explained calmly. The shark detected the disturbance and identified it as potential prey. Note the speed of response and the commitment to the attack. No hesitation, no warning. Chris watched his classmates' reactions. They were seeing firsthand what he had tried to explain. The pure, efficient, predatory nature that had made sharks Earth's most successful hunters for hundreds of millions of years. Now, the professor continued, imagine evolving on a world where creatures like this were just one of many dangers. This gives us context for understanding human psychology and social development. Dean Vorex turned to Chris. Did your ancestors hunt these creatures? Chris nodded. Some human cultures have hunted sharks for thousands of years. Others worshipped them as gods. Most feared them. Even today, with all our technology, humans treat sharks with extreme caution. Yet you protect them now, the dean observed. My research shows that many human nations have laws preventing shark hunting. We've learned that apex predators are essential for healthy ecosystems, Chris explained. Without sharks, ocean food webs fall apart. Smaller predators become too numerous, prey species get wiped out, and eventually the whole system collapses. One of the younger students, a floating gas-based being named Oliver White, raised a tendril. Does living with such dangerous creatures make humans more aggressive? Chris considered the question carefully. Not aggressive exactly, more aware. Humans are constantly scanning for threats, preparing for problems, thinking about what could go wrong. We call it anxiety or caution, depending on the situation. A survival adaptation, Professor Zilthrak noted. Species from safer worlds often lack this vigilance. As the demonstration continued, students took turns observing the simulated shark's reactions to different stimuli. Chris found himself explaining concepts he'd taken for granted all his life. Why humans were simultaneously fascinated by and afraid of deep water. Why shark attack stories made global news despite their rarity, and how living with powerful predators had shaped human culture. Later, as the lecture ended, Dean Vorex approached Chris privately. Martinez, your perspective has been illuminating, the dean said. The Academy prides itself on understanding diverse evolutionary paths, yet we've perhaps underestimated the impact of living alongside efficient predators. Thank you, sir, Chris replied. I'm just glad people are interested. More than interested, the dean said. The faculty is discussing a new research initiative on Deathworld adaptation strategies, with Earth as a primary case study. We would value your participation. As Chris left the lecture hall, he noticed several students looking at him differently. Not with the old pity or condescension, but with a new kind of respect. They were beginning to understand that coming from a world with creatures like sharks didn't make humans weak. It had made them resilient in ways that safer worlds couldn't imagine. The news of a special research project on Deathworld species spread quickly through the academy. Chris found himself invited to join a small team that would meet weekly in the Advanced Xenobiology Lab. The team included Professor Zilthrak, Lisa, Chen, Zorn, Gary Peters, and 2 senior researchers who specialized in evolutionary adaptation. Their first meeting was scheduled for the day after the shark demonstration. Chris arrived early, feeling both nervous and excited. The lab was much larger than the student facilities he was used to. Advanced holographic equipment lined the walls, and specimen samples from hundreds of worlds were stored in preservation. Units, Professor Zilthrak greeted him with a clicking of mandibles. Martinez, excellent timing. We have a communication request you might find interesting. The professor activated the lab's main communication screen. The image flickered, and Chris was surprised to see a human face appear. Dr. Helen Grant, Earth's leading marine biologist and the director of the Global Ocean Research Initiative. Chris Martinez, I'm Dr. Grant. The Galactic Academy contacted our department about your presentation on sharks and their evolutionary significance, she said with a smile. I understand you've caused quite a stir up there. Chris felt his face grow warm. I was just explaining why sharks are important predators, Dr. Grant. Well, your explanation has attracted attention beyond the Academy. The Interspecies Scientific Council is now requesting more detailed information about Earth's marine predators. They're particularly interested in how sharks have maintained evolutionary stability while adapting to changing conditions. Professor Zilthrak stepped forward. Dr. Grant has graciously offered to provide us with research materials and live footage from Earth's oceans. This will form the foundation of our project. The other team members arrived as Dr. Grant explained the package of information she would be sending. When the call ended, Professor Zilthrak turned to address the group. Our research project has 2 primary goals, he explained. First, to understand how predator-prey relationships on Deathworlds differ from those on more stable planets. Second, to analyze how intelligent species evolve when sharing their world with efficient predators. Lisa raised a tentacle. Professor, what exactly makes Earth a Deathworld? The classification has always seemed subjective to me. The professor activated a holographic display showing various planetary classifications. A good question. The Galactic Standard defines a Deathworld as any planet where environmental factors present consistent lethal threats to intelligent life. These can include extreme weather, dangerous flora and fauna, frequent natural disasters, or high levels of background radiation. Earth qualifies in several categories, Chris added. We have regions with extreme temperatures, regular natural disasters like hurricanes and earthquakes, and many dangerous animals both on land and in our oceans. Precisely, Professor Zilthrak agreed. What makes Earth particularly interesting is that humans evolved without dominating their environment until relatively recently. For most of your species' history, you were not the apex predator. The team spent the next hour reviewing the initial data Dr. Grant had sent. There were detailed scans of shark anatomy from dozens of species, videos of hunting behaviors, and evolutionary charts showing how sharks had adapted over hundreds of millions of years. Gary Peters, the Vespian student with translucent skin, studied the footage of a great white shark hunting seals near an island. The precision is remarkable, he noted, his inner organs pulsing with what Chris had learned was excitement. It times its attack perfectly with the seal's movement. Sharks have had hundreds of millions of years to perfect their hunting techniques, Chris explained. Each species has specialized methods. Some hunt in groups, others are ambush predators, and some chase down their prey. Later that day, the team moved to the Academy's environmental simulation chamber. This advanced facility could recreate the conditions of any planet, allowing students to experience different worlds without leaving the Academy. Today, Professor Zilthrak announced, we will be experiencing a simulated Earth-ocean environment. The chamber will recreate the pressure, salinity, temperature, and light conditions of Earth's tropical waters. The team members wore their environmental suits as they entered the chamber. For Chris, it was strangely comforting. The familiar blue of ocean water, the gentle sway of simulated currents, the distant sound of waves. For his alien classmates, it was an entirely new experience. The gravity feels strange, Zorn commented, his green skin glowing slightly in the blue light. And the pressure of the water, it's both heavy and supportive. This is only set to about 30 feet deep, Chris said. Earth's oceans go down to about 36,000 feet in the deepest parts. Lisa's tentacles moved gracefully in the water. As a cephalian, I find this environment quite natural. My ancestors evolved in similar conditions, though our oceans were much less oxygenated than Earth's. Professor Zilthrak activated the next phase of the simulation. Suddenly, holographic marine life appeared around them. Colorful fish darting through coral formations, rays gliding along the sandy bottom, and small crustaceans scuttling for cover. This is a typical reef ecosystem, the professor explained. Now pay close attention to what happens when we introduce a predator. A shadow passed overhead, and a holographic reef shark about 6 feet long entered the scene. Immediately, the behavior of all other creatures changed. Small fish darted into coral crevices, larger fish formed tighter groups, and some simply froze in place. Notice the immediate response, Professor Zilthrak pointed out. Every creature in this ecosystem has evolved with an awareness of the predator. They all know exactly what to do when a shark appears. The simulation continued, showing how the shark patrolled the reef, how it selected prey, and how it used the environment to its advantage when hunting. Now, the professor said, imagine being an early human, entering this world with no natural adaptations for aquatic life. No sharp teeth, no powerful jaws, no speed in water, just intelligence and the ability to learn. The group fell silent, contemplating this scenario. Chris had never thought about it quite this way before. How brave or desperate his ancestors must have been to venture into waters ruled by creatures perfectly evolved for killing. Yet humans did enter the water, Professor Zilthrak continued. They built boats, created fishing tools, and eventually learned to swim and dive in shark territory. This reveals something fundamental about your species, Martinez. A willingness to face apex predators on their own ground, armed with nothing but intelligence and tools. After the simulation ended and they exited the chamber, the team gathered to discuss their observations. For the first time, Chris felt he was being seen as more than just the token human student. His classmates were genuinely interested in understanding how Earth's dangerous environment had shaped human evolution and psychology. As the session concluded, Professor Zilthrak made an announcement that surprised everyone. Next week, we will be joined by a distinguished guest. The Galactic Council's chief xenobiologist, Dr. Kel Varan, will be visiting to observe our research. This project has attracted significant attention. Chris realized that his simple presentation about sharks had grown into something much larger, a reconsideration of how the galactic community viewed humans and their homeworld. Far from being dismissed as weak creatures from an unremarkable planet, humans were beginning to be recognized as survivors of a world that had shaped them through constant challenge and danger. The day of Dr. Kelvaran's visit arrived, bringing a buzz of excitement to the Academy. The Galactic Council's chief xenobiologist was a legendary figure, known for discovering the unified theory of cross-species evolution that had revolutionized the field. Chris had only seen pictures of the tall, elegant being whose scales shifted colors based on emotional states. The special research team gathered in the Academy's Grand Lecture Hall, which had been prepared for a formal presentation. Students and faculty from all departments filled the seats, eager to witness the historic event. Chris sat with his teammates in the front row, feeling both proud and nervous. Dean Vorex took the stage first. Today marks an important moment for the Galactic Academy of Xenobiology. Our understanding of interspecies development is continuously evolving, and sometimes we must reconsider our assumptions. The Dean's silver skin rippled as he spoke. I am pleased to welcome Dr. Kelvaran of the Galactic Council. Dr. Kelvaran glided onto the stage, scales shimmering with a deep blue that indicated scholarly focus. The tall serpentine being had 3 pairs of arms and moved with fluid grace. Thank you for the welcome, Dr. Kelvaran said, voice resonant and clear. I have reviewed the preliminary findings of your research team with great interest. The evolution of intelligent species on Deathworlds presents unique insights into adaptability and survival. Professor Zilthrak joined them on stage, mandibles clicking respectfully. With your permission, we would like to present our findings on Earth's marine predators and their influence on human evolution. Dr. Kelvaran gestured approval with one elegant hand. Please proceed. The lights dimmed and a massive holographic display activated. The first image showed Earth from space, its blue oceans covering most of the surface. This is Sol 3, known to its inhabitants as Earth, Professor Zilthrak began. A Class 3 death world, where humans evolved. While not the most dangerous planet in the galaxy, Earth presents numerous challenges to survival, including its marine ecosystems. The hologram zoomed in to show Earth's oceans and the diverse life within them. Professor Zilthrak explained how sharks had evolved over hundreds of millions of years, surviving multiple extinction events that had wiped out countless other species. Then Chris was called to the stage. He stood beside Professor Zilthrak, facing the largest audience he had ever addressed. Human Martinez will share his species' perspective on evolving alongside efficient predators, the professor announced. Chris took a deep breath. For most of human history, we were not the dominant species on our planet. We shared Earth with creatures perfectly evolved for killing, both on land and in water. Sharks represent the oldest and most successful of these predators. He activated a series of videos showing different shark species hunting in their natural habitats. The audience watched with rapt attention as great whites breached to catch seals, tiger sharks prowled shallow waters, and hammerheads hunted in coordinated groups. Humans learned early that entering the water meant entering shark territory, Chris continued. Yet we did it anyway. We built boats, developed fishing techniques, and eventually learned to swim and dive in waters where we were neither the fastest nor the strongest. Dr. Kelvaran's scales shifted to a curious green gold. This willingness to enter hostile environments is unusual. Most intelligent species avoid areas dominated by apex predators. Necessity drove us initially, Chris explained. Oceans provided food and transportation. But something else happened over time. Humans developed a complex relationship with the ocean and its predators. We learned to respect their power while finding ways to coexist. Lisa Chen joined them on stage, adding her perspective as a comparative evolutionary specialist. Our research indicates that species from death worlds develop different problem-solving approaches than those from safer environments. They anticipate threats, plan for worst-case scenarios, and maintain heightened awareness. In human psychology, Chris added, we call this healthy paranoia, the ability to recognize potential dangers without being paralyzed by fear. Dr. Kelvaran listened intently, occasionally asking insightful questions. When the formal presentation concluded, the distinguished visitor addressed the audience. The Galactic Council has long classified worlds based on environmental danger levels, Dr. Kelvaran said. What we have perhaps overlooked is how these dangers shape the psychology and problem-solving abilities of the species that evolve there. The xenobiologist turned to face Chris directly. Human Martinez, your species is relatively new to the galactic community. Humans have been viewed as physically unimpressive compared to many other species. What this research suggests is that we have been measuring the wrong attributes. A murmur ran through the audience. Dr. Kelvaran continued, scales now pulsing with the deep purple of profound realization. A species that evolved alongside creatures like these sharks, predators that have remained fundamentally unchanged for hundreds of millions of years, would develop different survival strategies than species from more forgiving worlds. Not physical strength, but adaptability. Not natural weapons, but problem-solving intelligence. Not specialized defenses, but generalized risk assessment and management. The xenobiologist gestured to the entire research team. This project has implications beyond simple biological classification. It suggests we should reevaluate how we understand the psychological and cultural development of all intelligent species based on their evolutionary challenges. After the presentation, a reception was held in the Academy's Grand Hall. Chris found himself approached by students and faculty who had previously paid him little attention. Many wanted to know more about Earth's other predators, about human history, about how his species had managed to become spacefaring despite evolving on a world with so many dangers. Dr. Kelvaran sought Chris out personally. Human Martinez, the Council will be revising our educational materials regarding Earth and human evolutionary psychology based on your team's findings. Your perspective has been invaluable. Thank you, Doctor, Chris replied, still somewhat overwhelmed by the attention. I never expected a class presentation about sharks to lead to this. The best scientific discoveries often begin with simple observations, Dr. Kelvaran said, scales shimmering with wisdom. Your willingness to share your species' relationship with Earth's predators has opened new avenues of understanding. As the evening concluded, Chris found himself standing with his research teammates. They had moved beyond being mere classmates now. Through their shared work, they had developed a deeper respect for each other's perspectives. What happens next? Zorn asked, green skin glowing softly in the dimmed lights of the reception hall. The research continues, Professor Zilthrak replied, but with a broader focus. We will be examining how different planetary dangers shape the development of intelligence across the galaxy. And you, Martinez? Lisa asked. Will you continue specializing in comparative evolutionary biology? Chris nodded, feeling more certain of his path than ever before. Yes, but I think there's something else important to share with the galactic community. What's that? Gary Peters asked, his translucent skin showing his curious heartbeat. That surviving alongside predators like sharks didn't just make humans cautious or paranoid, Chris explained. It also taught us to appreciate beauty and danger, to respect power we can't control, and to protect even those creatures that could harm us. Humans don't just fear sharks. We study them, admire them, and now work to ensure their survival. Professor. Zilthrak's mandibles clicked thoughtfully. Perhaps that is the most important lesson of all, that true intelligence isn't measured by dominance over other species, but by understanding one's place in a complex ecosystem. As Chris looked around at his alien colleagues, he realized that his small presentation about sharks had done more than just change how they viewed humans. It had helped bridge the gap between different evolutionary paths, different worlds, and different ways of thinking. In trying to explain sharks, he had helped explain humanity itself.